This is Unevenly Distributed, a podcast from Nexavize.com, where we talk to experts to find out what's next in digital technology and where it's real today.
This is Unevenly Distributed, a future tech podcast, and I am Jeff Ilimek. Today I'm joined by Fergus Kidd, a colleague of mine from my days at Avanade. And Fergus is Avanade's Emerging Technology Research and Development Engineering Lead. Fergus, welcome.
Hey, Jeff. How's it going?
It is going great, and I do love that title. I think we talked a little bit about this in the lead up. I like that differentiation between pure research and science and engineering, where we're trying to make things real. Yeah, and we're going to talk about that a little bit today. Yeah. It's been interesting. So I've done a couple of these episodes so far about AI. One was a foundational discussion with Six, where we talked about what it takes to generate these models, mostly in the focus of green software and green computing. And I know you were part of the research that went into what Six is working on, so sort of co-developing some of that talk with Six. I also talked in general sense with Rachel Levy of Google about where AI has come in the last couple of years, model drift, where we're at. We even by the end got into some discussion around sentient AI. We tried to stay away from the sensational headlines, but we talked a little bit about that. But what I was really excited to do is, after getting some of that foundational discussion around AI in place, I'm most excited about the evolution of AI and where it's going to go. If we think back 5 years, 6 years ago, we were all very excited about creating some of the models because we had this confluence of hardware and updated view of how these algorithms could be created. And we were all able to start creating models, and they all mostly started around recognition. We're going to do face recognition. We're going to do voice recognition. We're going to recognize images. And then we started not long after, couple years after, to get to the point where we've got this big matrix of all of these pieces which make up the image of a face. And somebody got the idea to then ask the question back, to go backwards basically through the graph and say, okay, you now generate for me based about this deconstruction that you've got, and this is sort of a rough way to talk about it, but you model, show me a face. And I think that was the leading edge of kind of what we want to talk about here, which is the generation of synthetic images, data, models, things that are coming out of the AI, things that the AI is creating with us or for us or on its own creating, which is sort of really a generation or two beyond where we started after this last AI winter, going back 5, 6, 7 years ago. So to introduce it there, to sort of get us at that point of the jumping off point, why don't you talk a little bit about what you've been doing in terms of research lately around that, what that looks like, and then we'll break it down into some specifics.
Sure. Yeah. Well, my role, I often describe my role as just getting to play with the cool toys. So a lot of it is about, actually trying out the engineering on some of these awesome frontier topics and seeing what we can do, and actually having a play around with them, and then thinking like how those can be, put into use in the enterprise. So in these topics, we've actually been going, as you said, we're looking back a fair while to actually people making useful products and services out of the notion of like generative AI. I think we're now at a point where it's really kind of mind-blowingly good, though, and we'll talk a little bit about that today. But things like synthetic data sets have been going on for years. If we think about just like text input and numerical input, especially, there's statistical methods and models for simulating some of that data that go back quite a way. And we've had bits and pieces that have worked for the more visual stuff, which we'll look at, but never really that great. A lot of it is focused around kind of fun things to do, things like Snapchat filters, things like the apps that make your profile picture look like a certain cartoon style, like not necessarily the best use cases ever, and that's mainly been like a limitation of the technology.
Right. That evolution, and yes, we've been doing that kind of thing. You sort of introduced a couple terms which I think it's useful for us to define. One is the generation of synthetic data. At its core, this is something that is certainly very useful in business and is demanded in business in a lot of cases. Just a synthetic data set that we can do work on or can ride alongside a system that we're developing or being used to test the kinds of analytics we want to experiment with. Generation of synthetic data sets is something we've been doing it back since the initiation of computing. And some of it was just, here's a random number generator generating addresses for whatever.
Mm-hmm.
Procedural generation of synthetic data sets is interesting. Now that we've gotten these intelligent models and the generation of synthetic images and very complex synthetic data sets, I think it's come a long way, as you said, and it's getting scary good in a couple different ways. And we'll give some examples of that. But I think the real next step in that is beyond, here's a synthetic thing I asked for. It's, here's a synthetic thing I asked for by combining multiple concepts. So now not only do we have to have an image that understands what a dog is, and then I could ask it for a dog, but we're having models and these multiple models that understand the relationships between objects and as they're interacting, say in a visual case, so that I can ask for a complex model like a dog on a motorcycle. In order to generate that image, you need to know what a dog is. You need to know what a motorcycle is. You also need to know how they would potentially fit together. How does anyone ride a motorcycle? What does that look like? What does riding a motorcycle look like compared to a motorcycle by itself? And how would you put that together to create an image that's a dog on a motorcycle? That's very complex. And those interrelationships is kind of the next generation. And I don't think we would have been able to, in any reasonable amount of time, because of compute and hardware and the design of these algorithms, to be able to do that 10 years ago. Of course, I don't think that's possible. So that's really exciting. The most sensational examples of that, maybe a place that I just want to start, is something like DALL-E, right? And I know you've done some experimentation with DALL-E. There's a couple other of these image generation engines out there. What is the other one that I was experimenting with lately? Midjourney, I think.
Midjourney's one.
That's another one, and there's a handful of them. DALL-E, DALL-E 2. The advancement of this. Why don't you describe what it does and what it looks like? And for the people that are watching visually, you can either, or if you're listening in audio, you can just look it up. We, in the video version, will probably show a couple pieces of this, but describe what it looks like and where it's come and where it's gone to, and why it's really interesting right now.
Absolutely. I think, well, what it looks like is pretty simple, right? There's just a text prompt. As you said, we can say something like a dog on a motorcycle. And what we get back after a little wait is 4 images of dogs on motorcycles. So, I mean, we can give it a go.
So Fergus has DALL-E 2 up here. Is it DALL-E 2? Is this?
It is, yeah.
And is typing in.
So it'll go off and generate. And I mean, it's as simple as that. It's just a text prompt, and what we'll get back is a load of images. And I think, as you said, actually the kind of quite severe complexity behind that is really the understanding. So there we have, 4 pictures, 4 different types of dogs on 4 different types of motorcycle. And I think it's kind of more than just understanding of like, there's a dog, there's a motorcycle and on, but there's also the contextual awareness of the human language. What does a human expect to see? Or what would a human draw when they said a dog on a motorcycle? There's kind of a literal interpretation. We haven't specified which orientation the motorcycle is, whether it's like lying on its side. Here we see that they're all pretty much stood up on 2 wheels, as we would expect to see a motorcycle. But there's like lots of other literal ways that we can take the phrase a photo of a dog on a motorcycle, where that dog is, what the dog is doing. But DALL-E 2 is also kind of able to take those notions from the human language to generate something that actually you or I, if we were asked to draw this or maybe put it together in Photoshop, would actually aspire to do something that good. Because I mean, I certainly don't have the artistic or creative skills to get to this level of fidelity. That if you can see the video, you can see that it's like pretty good. I mean, there are problems with it. If we look
sure
at one of these, for example, it doesn't look like this dog has clearly defined eyes. It looks a little bit more like a toy, for example, but there's definitely a well-defined motorcycle in there. there's even, some quite complex artifacts. So this one has a rear view mirror in it, and it looks like there's a reflection in that mirror even. So some really high level kind of understanding of what should be going on in the scene, how the framing of the scene works as well. Um, I've got another one up here where the dog is actually wearing a motorcycle helmet.
Yeah.
So DALL-E also understands that like safety may be an important
Or
and relevant thing to have in
or
this
when
image.
humans say, show me on a motorcycle or a person on a motorcycle, they often wear helmets and sort of putting those pieces together. And as you said, that the context, if we say dog on a motorcycle, as you suggest, it could have been, a motorcycle laying on the ground and a dog standing on it, but that's not what we would expect. So the language, sort of a Lewis type model, a language understanding the context, understanding the visual aspects. What is a motorcycle? What is a dog? What are how do we typically expect to see them represented in the world for real? And then, just the art aspects, as you said, there's a lot going on here in terms of being able to assemble an image from those parts, being able to sort of do the photoshopping. I don't know how much you use Photoshop. I use Photoshop quite a bit. And Photoshop, in terms of user interface, is relatively opaque. I can find the simplest thing. I've got an image. It's 16 by 9. I just want to crop a square out of it. I have to go to YouTube. Even I've been using Photoshop for years. I have to go to YouTube to figure out how to crop this image. Oh, well, you need to create a block, and you need to do masking, and then you invert the mask. An AI which even understands how to assemble these kinds of images, that's amazing to me. So that's a great move.
Yeah. And I guess the like important thing to note is that it doesn't know how to use Photoshop.
Right.
It's just the amalgamation of different images is done so well through the deep learning, the deep neural network or whatever DALL-E has in the background, that it just knows how things should look. And I think that's like, for me, a huge kind of like cherry on top of this is that all of the photos you get back look like they've all correctly scaled. They look as if they could be real compositions.
Yeah.
Unless we kind of tell it to produce something else. But thinking about like Photoshop, I do a lot of 3D modeling for like various things and 3D rendering. And again, like tools like Blender are pretty notoriously difficult to use. They have like a very steep learning curve. Once you're familiar with it, you can just basically do everything through keyboard shortcuts. But it takes, hours of work to model some of this stuff out. But if I just type a 3D render instead of typing a photograph of a dog on a motorcycle, we'll have a look at what that comes back with. But DALL-E also understands like the different concepts of human art. Humans use different tools, paintbrushes, pens, cameras, or 3D render engines and Blender to create some of this stuff. And DALL-E 2 also like has an understanding of that and art styles, which I think is really cool. So what we can see now is four very different style dogs on a motorcycle. They're kind of 3D
cartoony, lower
motorcycles.
Poly, which you would expect if you told an artist to go into Blender or a modeling tool, Maya, and put something together. But very
Absolutely.
recognizable as that.
We've got 4 here, right? It would take us hours to do one alone, and now we have 4 options. I can even, if I particularly liked one, say I like one of them more than others, I can also just go in and click variation. And what it will do is take that same image that we have and then generate variations of that image. So in this one, we've got kind of a light brown dog on one of those cartoony motorcycles. And what we'll get back is 3 more pictures of similar looking dogs. The motorcycle is facing the same way. It's kind of a similar style of motorcycle, but still very, very different looking dogs. If this was like a Pixar film or something, these could be 4 different characters, for example, because they're not all exactly the same. So sometimes that's beneficial because we can get like lots of different outputs, lots of cool similar images. Sometimes it's a bit like detracting. The one thing I guess we couldn't do is have the exact same dog on the left do something else. So we couldn't ask for this dog juggling, for example, because DALL-E has presently has no ability to remember how it rendered that image or what that dog actually is or looks like. there's a lot of work going into reproducibility of some of the prompts. So how do you form a prompt in order to get repeatable results? Because often we'll get quite different results every time we like push something through the neural net.
Yeah.
And that's just really a factor of there being so much data behind this and so many images behind this stuff that we do it 100 times, we get 100 different results.
A graph of millions of small components that are going into creating this, and multiple models as well. It's not just, here's just one single model and you ask for it, because it's got different things that are happening at different points, and you've got these sort of blocks within the system that are outputting the image. This does remind me of some discussion, and there was an article in Vox recently about, you think about GPT-3 or DALL-E and bias. So asking it for, say, I want an image of a nurse. Show me an image of a nurse. And it shows you a bunch of what is the most common vision of a nurse based on the things that are tagged as nurse on image, Google image search or whatever. And it doesn't show you the 75-year-old, 300-pound, 6'4" guy with, full sleeve tattoos riding a motorcycle. That could very well be a nurse as well, but that's not necessarily what we expect. So I think there's pros and cons to thinking and talking about the bias problem. So why don't we talk about that for just a second? What's your perspective on the bias problem, and then what we should, and where I end up coming to, is what we should and shouldn't even bother to ask this kind of model to produce for us if we don't want to experience the bias in the data.
There's a couple of points I'd make. One is that it's almost impossible to avoid the bias, right? When the training sets are this large and they're based on open internet data, you're inevitably going to get things come through that, because the internet is, at the end of the day, an awful place to get information and data
or
from.
There is bias. There is natural bias just because, the preponderance of people that do a particular thing for no good or bad reason, take rationale out of it. But, more women right now in the workforce are nurses than men are. There is a split, and there's opportunities there in all places. But when you're asking a data set just to say, what does the data look like? It's basically reporting back to you some analytics in the same way that you might want to do a statistical analysis to determine where you can invest to get more women into coding, for example. It's reporting back to you in a way.
Yeah, that's a good point.
In that, though, I think one of the advantages to, you could say, show me a nurse. I think that's the least interesting thing to ask DALL-E to do. One is, if I wanted to get a report back of where there seems to be bias in the data, I could ask that kind of question. Two, if I want to create interesting art, maybe that's not a question I should ask. Don't show me nurse. Maybe I need to, because this is what DALL-E does, add the characteristics. Show me, a Harley biker gang member who is also a nurse. I don't know what it would do if you asked it to do that.
Yeah.
But if I'm trying to create a creative vision, for one, or for two, if I'm trying to break down bias, if I'm trying to identify those exceptions, which is what we celebrate when we're trying to look for diverse outcomes, then I shouldn't ask the open-ended question, which just shows me the preponderance of what the norm happens to be, because maybe we don't like the norm and we want to change that. That's, I think, a way to think about that.
Absolutely. And I think with DALL-E as a specific example, the more specific the input is, the better the output tends to be. Like when you leave statements quite generic, it will be, it will be making up as much as it needs to fill in the gap. But the more specific you are, the better result you're going to be. So some of these prompts can be quite long. For example, I always put in the art style, like whether it's a photograph, whether it's digital art, whether it's a 3D rendering. Because if you don't specify what you want out of it, it's going to give you a selection because it doesn't know. In the same way, when we think about like the nurse question, I've just done it for one of the kind of case studies for the ethics of this that I read about originally was not a nurse, but a judge. So if you ask these systems to give you a picture of a judge, it would often just give you 4 pictures of older
Yep.
white males because that's what it had seen from the
Right.
data. So there's one thing which is we could be more specific. We should say, show me a female
Right.
judge or show me, anything else that we would like to see, because at the end of the day, it's us generating the image for a reason. So we have to think like about the reason. DALL-E has a whole load of content policy anyway that we'll talk about. But one nice thing that Microsoft have been very, very keen to do whilst developing both GPT-3 and DALL-E is to be aware of these biases, be aware of the ethical implications. Hence, we get things like a very comprehensive content policy, which really does work. I've tried to push it to its limits, but we can have an open conversation about that as well. But you do get content policy warnings, and it says your account will be suspended, and it doesn't actually generate the images for
Interesting.
you. But the other thing is they have definitely taken account of the bias. So here we have 4 images. All I've said is a photograph of a judge in a court, right? Fairly open ended. I haven't said what the court should look like. Actually, we've got 4 fairly similar looking courts. You could probably guess that all of these would be, in the United States, or at least a Western nation in terms of their like setup and the way they look. But we've got 2 older gray-haired male judges. We have what looks to me like a female judge, but is just because of there's an earring. It's interestingly kind of cut the top of her head off. And then we have a black judge on the right as well. So there is, originally when this kind of like the research was done on the ethics of these generative systems, it was coming out with, majority white males. In this example, we've just tried it live. We've got 50% white older males and 50% not. So that there is at least some nudging going on behind the scenes somewhere. What exactly that entails or looks like, we don't know, but it seems to be working. And what I've found through my experimentation is that when you ask for like generic groups of people, it will actually try, DALL-E 2 specifically will actually try and not mix up, but try and provide different genders, different ethnicities, which is really, really interesting. So if you actually want to depict a group of all white males for whatever reason, then you have to say that. And that really actually makes you think, why do I want a group of all white males for this particular purpose, whatever it is? One example I have of that is I was at a barbecue talking to a group of friends about DALL-E and what it can do. And they had been telling a story about a specific event that had occurred. So I said, oh, well, let's see what the AI thinks that event looked like. And the first time you generate it, which is a group of people, it will show people who don't look like the people you're trying to portray in the story. So then you have to be more specific, saying, one tall blonde person, one short brown-haired person, whatever it is, to get a more accurate of what you're actually trying to achieve. And then you can start thinking, why do I want it to look the way it is? Is it because I'm trying to reproduce a specific person, which by the way is not a good idea to do ethically, try and like recreate a specific person? Or as you said, is it just taking like a cross section of the data that's behind it and giving you a mix of options?
I think there's a lot of uses, and maybe that's what we'll talk about. Yes. Next, I think one of the least interesting uses of something like DALL-E is to try to generate pictures of people in situations, because there's a lot of intentional design and that needs to go in to create a balanced representation of what you're trying to create. If you're trying to create just an interesting side image of a dog on a motorcycle, you're still potentially going to want to be very specific, potentially, but it probably has a lot less social impact if there's bias in a data set of what people think dogs are. And we can be cognizant of that. And being cognizant of it, for one, both in the creation of the models and in the use of the models, is the root of digital ethics around this, which I think is important. But let's talk about some of those uses of this. And so you said we can even ask for styles in DALL-E, and Midjourney as another example of this, I think even leans more heavily towards the stylized creation of art, which I think is interesting. So it's much more stylized than even DALL-E, which I think is even more useful in sort of the more realistic depictions. But where would you see this start to be used and useful in sort of teaming up with us as creators in either in industry or in creative disciplines? Where do you see examples of this being useful?
I think there's lots and lots of different examples. For me, from where I work in tech, the obvious ones are anywhere that we use stock imagery, right? Whenever we use a stock image, that's something that has to be set up, created. It's often very difficult to find relevant
Hmm.
enough stock images. And we can talk through a specific example that I've used in a blog post before. But anything where we would use stock images, whether that's in like publications, in media, to illustrate a point, we can actually do more accurately or more as if we had rented a studio or hired a 3D digital artist, which wouldn't be a good use of time and resources normally if we just written a blog or we had a newspaper article that we wanted a specific visualization for. It wouldn't be a good use of people's time to go and recreate that photo perfectly. Whereas with DALL-E, we can get lots of different iterations. We can get lots of different angles. And that's also useful for just content generation in general. If you're still in the ideation phase, if you're still thinking about what things should look like, you can ask DALL-E for like different examples and start to, get ideas from another input at the design phase. A huge one for us is wireframing and like user interfaces. So when we build out wireframes and do user interface testing, we often have placeholder text, which is, often you'll see lorem ipsum and things like that, which is the nonsensical Latin phrases that they use to fill out space. And you'll have like irrelevant images. And it's pretty hard to do user testing on those things because people will be distracted that they can't read the text, or they'll be
Right.
looking at things that they'll focus in on that this image looks wrong, or there's something, it's just a drawing of the image. With DALL-E, we can, with GPT-3 and DALL-E, we can actually create placeholder content that is much more relevant to what we're actually looking at. So we can do some of that user testing, and we can decide actually we don't need this page, we don't need this block of text. There should be more images here, without actually having to go through the cost of generating those beforehand. So then when we actually get to production of a website or whatever it might be, you're only paying to professionally make the content that you actually need, because you've used like a lot of placeholder text. So that's like a couple of examples I
No,
can
that's
think of.
that's
But there's
great.
probably
Any of these kind of creative disciplines is using it for inspiration, as you said, even if you aren't going to use it as in an
Mhm.
end product, using it for wireframing. That is a great example that I hadn't really been thinking about. Upping the fidelity of what you're creating to be able to do user interface testing, to be able to put out different examples of sample data into a user interface that you've designed. I would wonder as this advances, and we'll talk a bit about Copilot in just a second, but even having it, I don't think this really exists yet. It would do it in a really high fidelity way that would make sense from a user interface presentation perspective. But what about it creating different user interfaces, arrangements of the data? Here's a data set that we need to be arranging on a form. Do it in a way that's most effective for this type of group of people. For executives versus line workers versus people in the field. That would be pretty
Yeah,
fascinating
I
to
think,
me.
as you said, with DALL-E specifically, it's really a system of quite complicated models. There's the language understanding, there's the image understanding. But actually, by taking some of those modules and shifting them around for different purposes, we could probably, get to a point where we could make a DALL-E for user interfaces. One of the things that through my experimentation I've noticed, for example, is because graphic design is a huge industry. Um, DALL-E's not very good at making logos. I don't know why. I don't know what it is. Unless you have the idea for a logo, if you just say, "Hey, I want a logo for something," then DALL-E is not very good at taking the context of, it's for a technology company, therefore it should probably have something to do with technology. It just kind of goes for, and it's really, really not very good at words and writing, which
Mm.
is a bit strange because, there's lots and lots of data on that. There's loads of work been done around optical character recognition, and you would assume that it's quite easy to do, whereas actually it's a whole nother, level of understanding and context about the text. So if you ask it for something like, a neon sign of a word, it will almost inevitably get the word wrong or jumbled up
Or
or
swirly or
something
not
wrong with it because
recognizable
it
letters.
doesn't
Yeah.
exactly. And in the same way, it's not very good at logos and icons. You have to be very specific, saying like, I want a logo of, a bird, or you have to kind of describe what you want to see. So I think there's loads of potential for more niche use cases where you actually use the same modules and workings behind the scene in a slightly different way to get a different result.
This is fascinating, the generation of logos and art. I, as now a content creator, I have a few podcasts that I do. One of my oldest podcasts that I did a fun side podcast about video game, a particular video game. I have been using for many years AI generated theme music for that podcast,
Hmm.
where you were able to put in factors of how fast you wanted it, what kind of feeling you wanted to generate, and I wanted it to be like a little, techie and space, because that was the kind of video game that we were talking about. And it was, which is really useful in a lot of these cases, it was not copyrighted. There wasn't a license that I had to be paying on a regular basis in order to be able to use it. It was podcast safe. So that was great. The other thing that I forgot and haven't tried out yet, I am thinking about changing just some of the background graphics and logos on a couple of these podcasts. And I did some design of my own for for this podcast, for example. But it's a little bit boring. So I wonder if I can engage DALL-E to inspire me with some new designs, or even create a design for me that I can start to use.
Well, I think that you kind of hit the nail on the head there with the
Yeah.
inspire. So I've just typed in a graphic logo for a podcast for video games. In these examples, I don't really see anything specifically about video games. Okay, maybe in one there's what could be like a games controller or something, or it looks more like drumsticks to me. But there's still some like inspiration in there. It has not spelled podcast correctly once. We've got podcat, pogast, postat. Like it just can't seem to get. It gets the graphical elements of the
Right.
letters. It just can't really seem to get them in the right order. But again, for inspiration, this is fine. You think you could look at the one on the left, which looks like a pink splat with some blue text over the top, and you could think, yeah, that's cooler than what I came up with. And then you could, get Photoshop out, do a few YouTube tutorials, and
Yeah.
make that for yourself, but using the correct name and the correct placements.
Yeah, exactly. That inspiration, I think, is great. So let's expand it into a couple other places. We didn't explain in particular just yet where DALL-E comes from. It is from OpenAI, which is a uh, a company of its own, and it's supported by and funded by a few different places, including Microsoft, a couple other charitable foundations. But they've been doing a couple other interesting things besides DALL-E. You already mentioned GPT-3. Why don't we describe what that is? Because then the special use case of GPT-3 that I want to get into is Copilot. So define what GPT-3 is, and we can brainstorm on some of the uses of that we've seen so far, and go from there.
Sure. So I think really GPT-3 is actually a key component of
Mhm.
DALL-E because it's really about the text and the language understanding. It's a very, very large, open, text-based model, which we can ask anything to in human language and get a response in human language. And it's really very good and understandable. So there's lots of traditional use cases that we can think of when we think about text understanding. You mentioned Lewis earlier, like a language understanding that pulls out intents. So hey, what time is it? It has an intent of actually all I want is a piece of information about the time. Or turn the light on. Okay, I need to do something to a light. What do I need to do it? I need to turn it. What direction do I need to turn it? Turn it on. Like there's lots of different subtleties to the language. Um, GPT-3 can do all of that. Things like sentiment analysis, which used to be a separate model on its own. Something like a chatbot, which used to be a separate model and service on its own. GPT-3 is a much more generic language-based model that can do all of that and above. Um, one thing it can actually do is if we can't think of something to type into DALL-E, it can give us suggestions. It can do anything that we can type to do. So, I mean, I can type something like, what is a podcast? We've been talking about podcasts. What is it? Maybe I don't know. I can just type, what is a podcast? and then I get an answer back from it. So GPT-3 says, a podcast is a digital audio file made available on the internet for downloading to a computer or portable media player, typically available as a series, new episodes of which can be received by subscribers automatically. So that in this case is kind of like doing a Google search, except we've got a very specific sentence. I could change my request and say something like, write me an essay on podcasts. And again, like the understanding of the dog is on the motorcycle and what that really means, it understands that there's a different context to what I'm asking here. I'm instructing the model to do something different. So now we have like a few paragraphs of more of an emotional piece on podcasts. It's got some. So it starts off, I absolutely love podcasts. They're the perfect way to stay entertained and informed. So there's more relevance that you'd expect to get from an essay rather than just in a question and answer.
And make sure you like and subscribe. Did it say that? Because I think that's a podcast thing.
It didn't, but that is an area that it could be retrained on. But it does say, if you're not already listening to podcasts, I highly recommend giving them a try. I promise you won't be disappointed.
There we go. Thank you.
But
thank you, GPT-3.
But I find it really interesting that, just by changing a couple of words in that, I actually even misspelt it in the example because I was typing and looking in the wrong place. But it still even though I've made a mistake, it understands the context of what it's being asked to do. It understands the context of it should have, in an essay, it should have personal opinions. In a question, it shouldn't have personal opinions. It's just going to state you a factual answer. So there's so much more that we can do than just like FAQs and Google searches might have provided these answers for in some other when I say Google search, really mean just like a factual lookup search on the internet. This is really disseminating information from lots of different ways. And again, kind of stylizing it. So in the same way that DALL-E can style its outputs, its images in different ways, GPT-3 can style the text output depending on the use case. And it does this all through understanding. So using exactly the same interface and not changing anything, I could just write a chatbot that answers questions about podcasts. And then I could say me. So then this becomes like a chatbot immediately. And we're not doing anything else. I haven't built any code. I haven't done any, I haven't gone into Azure and opened a chatbot account or anything. So I can say like, what's your best recommended podcast? And then I'll just give it a little prompt for the AI to say something back. So we get an answer saying, there's a ton of great podcasts out there, but some of our favorites include This American Life, Serial, and Radiolab. So sorry, Jeff, you didn't make
I didn't make their top three. But those, that's a great answer. And as you said, intent of what you're trying to create. So there's multiple intents here. The intent of what the foundation is for wanting the context of the chatbot. It's understanding the context of the question. It's also understanding your intent in wanting it to turn itself into a conversational interface. That's a complex concept and goes beyond even just the understanding of language and spitting out representative text, which would address that language as in terms of an answer to a question.
If we just quickly go to the examples page, you can see just the amount of things it can do with one model. Before, these would have all been individual pieces of code or individual models or something. So we've got things like turning a mood to a color, classifying sentiment classifiers, summarization algorithms, explaining code, which we'll talk a little bit more in detail about. So many different features that would have been standalone APIs or standalone services, now just all in one place.
Which is fascinating. And when we talk about AI creating things, in this case, in addition to having all of these, some of the basic recognition models built in, that idea that it's helping you create something new. I've just now created a brand new chatbot that didn't exist before that answers questions about podcasts. It didn't have like 15 podcast bots that it now did recognition on and created one. It sort of created that out of context from scratch because it understands the relationships between these concepts and what it's like to create that kind of thing.
Yeah, no one's coded it to be able to understand about podcasts, right? It just does. if they had coded it, that you would never get to this stage if you'd had to code it. But the point that we were at before GPT-3 was made available, and it's available on Azure now even, is that you would have had to do all of that coding yourself. You would have had to write conversational flows, had FAQ logs, whereas now we can just use the kind of power of the internet, if you like, as well as the power of the algorithm to answer a lot of those questions.
And as we said, there's limitations to that, and you need to understand those limitations for what you're trying to do. And maybe it would be a representative bot that talks about podcasts, but maybe it has built-in biases. It doesn't give us a complete answer that's up to date for today in 2022 based on news that's happened in the past week. So you do need to understand that as well, and we need to be careful how we make use of this kind of thing. Now, there's a special use case that was built out of the GPT-3 model. I think the submodel that they created was called Codex, which turned into a product from Microsoft, which is Microsoft Copilot. Define that real quick, because I know what it is, and we can talk a little bit back and forth about it, but I am fascinated by Copilot, and I'm going to be using it relatively soon, and I'll explain how.
Sure. So Copilot very similarly can take that human understandable language, but specifically with Codex is it can translate that into code. So GPT-3 can also translate between languages, but Codex specifically has ingested thousands of code samples from different resources that's available, whether that be through like documentation or GitHub or public repositories or wherever it is. Again, we can have a whole separate conversation about like the biases and the problems of the biases in code. But what it allows you to do is to take human underrate code, so understandable language, and really quickly generate. You can really simply just write comments like a function to add X and Y and then divide by Z.
And Fergus is just typing this in sort of as a comment in the code. So say you opened up a coding editor and you needed to do this thing. It can, based off of those kind of comments, start actually writing the code for you.
And like DALL-E, without necessarily even having to know any Python or how to code, you kind of do need to, again, like GPT-3, you need to understand the limitations so that you can kind of type the right things. You know that you need a function, for example, so you can explain things correctly. But the output we get is absolutely connected to Copilot in all good live demos. But in this file, I actually produced all this code. We can see before. So we're looking at like opening up a webcam stream using Python, for example. Right. And I got entire functions, entire loops back. Like, again, mind-boggling, really.
Because it's real code, it's compilable code, it solves the problem that you're asking it to do based on context. And a lot of it is based on sample code, a lot of it's based on GitHub, maybe things like Stack Overflow. Brilliant coders can just sit down and code flows from their brain through their fingers into the keyboard. But mere mortal coders or old hacks like me that can barely code anymore these days, but used to be coders, I spend most of my time, I come up with, hey, I need an optimal way to sort a linked list. All right, let me go to Stack Overflow. let me go to GitHub and look for some sample code, and I'm gonna find out what a best practice is. Having a copilot, having an AI copilot, which can dump these things in directly as part of your workflow, it just seems invaluable to me. I've done some research. I've been looking at experienced coders out there on the web in their YouTube series. And when the idea of Copilot was first introduced and some of the initial flaws and some of the tech demos, you could see some progression in videos that they created. So you go back like a year ago, and there's a couple critical videos that they produced. A bunch of them now have like updated videos where they say, I was wrong. I was wrong about my initial perceptions of what Copilot is and does. It is really interesting and valuable and useful, and I'm going to be using it. So I agree. I've probably forgotten more about coding than I will ever learn again. But
But
one of my other podcasts is in the gaming industry. I talk to executives in gaming and developers, and I wanted to mess around with some sample code of my own. I'm going to need something like Copilot because otherwise I'll be
yeah,
spending the rest of my
but
time
I mean,
scouring GitHub and Stack Overflow constantly.
yeah, but even if you're, even if you're a very senior developer who's 100% confident and the code writes from your, flows out of your fingers, there's still going to be times where you need to look in the documentation just to see where the APIs are available. There's still going to be times where you need to, look things up on Stack Overflow, even if you're the one answering most of the questions. But what Copilot does is actually, if you're a very junior coder, super helpful because it will, show you how to format things correctly. It will show you the structure and will help you, flesh that code out very, very quickly. But if you're a senior developer, it just brings the documents to you. So if you are, writing with a library that's new to you, it's not necessarily new to Copilot. So you can even write things like, start. You could just type the class and then it will show you all of the different options available. You can actually cycle through different options as well. Or you can say, using this specific library, do this. And not only will it learn from other people's code, but it also learns from your code. So if you're a super high achieving developer, then you can actually have it do things which you would have to do by, you say you should never copy and paste it in code, but things that you might have to copy and paste and then change a few variables for, you can actually just get Copilot to do for you because it's kind of learned from you and understands your code, which is, I find, absolutely fascinating as well.
The inevitable question that comes after this is this going to take the place of developers and programmers? We described a concept on the last episode, which was digital centaur. And it's the AI plus the human being better than any one of either one of them alone. And I think that's very representative in something like this. Although it produces a very functional code block, in some cases it might not be the optimal case for that code block, or it might need to be tweaked or modified to fit the use case better. The human plus the AI working together can be faster, more efficient, more effective in terms of the right uses of nuances of the language that somebody may have just forgotten today. And being able to structure things as that digital centaur, I think, is where this is going to be most successful. So instead of getting rid of anyone's job, it's going to create richer, more effective, less buggy code, and it's going to make developers better. Do you agree, or do you think we're all going to get have new robot overlords?
No, I absolutely agree. I think I see these as tools, and they help different people in different ways. In the same way that, Excel probably put a lot of people out of business doing manual spreadsheets. No, I'll say that again. In the same way that Excel didn't put businesses out of business by revitalizing the way the workforce is working, it's just a tool that allows people to do things much more efficiently.
Right.
So, but it's different for everyone. If you're a junior developer, it will help you learn much, much quicker. If you're a senior developer, it might help you speed up like 2% of your activities, which you were doing because you're already at a comfortable place. But what none of the things that we've talked about so far do is achieve anything on their own. They have to be guided. They have to be told what to do. We have to review the output. For all of these, we have to review the output and say, is it good enough? For DALL-E, we have to say, like, which dog do I prefer? There are instances where we can just, pick one at random and it will probably be good enough. A chatbot's a good example of that. I often use GPT-3 in my chatbots when I don't have an FAQ answer. I don't have a Lewis intent for it. So I'll then send it out to GPT-3 and see what the response is because I don't have another answer. And GPT-3 will often give a much better answer than just saying, I'm sorry, I don't know how to deal with this query.
Interesting.
But, if we were writing a blog post with GPT-3, which I've done, a colleague of mine did it as an experiment. We wrote a blog post using GPT-3. We started to read through it and make sure that it was like displaying correct information. In the same way that a developer will still have to test the code, Copilot it can write the tests for you, but it currently can't test itself. It can't deploy itself to GitHub. So it's really just at the moment a tool for a specific part of the operation to help people do their jobs more efficiently and better. And I think, like many of these technologies and tools, they are quite specifically targeted to the points which take time out that aren't necessarily that useful. So coming up with 17 different visual ideas isn't actually like a helpful thing for a human to spend a lot of time doing. Choosing one and then developing on that is. Or if we think of the coding example, if you start a brand new project, a brand new repository, getting that base layer of code and functions out with the library you haven't used before isn't, or you have used before, isn't that helpful. So getting Copilot to help you flesh that out very, very quickly just means you can spend more time on the function that nobody's ever seen or written before that's solving a very particular niche problem. In the same way that, like, actually hiring a photo studio, hiring models, and getting them to actually produce the professional quality image that you need for whatever reason is the more useful thing to do. So it kind of helps make those processes more efficient and speed things along, rather than like replace things that people are actually doing full time, which I think is the important distinction. Like, none of the stuff we talked about today is really replacing what anybody currently is doing full time.
Right. I think that's really interesting. Two concepts in there. I think that it's great to reinforce. It's the digital centaur. It's making people more effective, and the different levels of effectiveness, as you suggested, are interesting. Making the more base elements of what we do. I need error logging. Error logging is not that interesting. It's not solving the business problem. It's something we need in our code. So if I can just get that dumped in based on whatever framework or tool set or libraries that I'm particularly using, great. And then I can focus on what the real business problem is and do something innovative. The other concept in there that I thought was fascinating that you described was the escalation and being able to use these as a fallback. So I may have a chatbot that has very specific, very well-tuned answers for the 10 questions which are the 80% of the value that people would come to my chatbot for. But in the other cases where it's a more general question or another kind of question, having the escalation of fallback, which is better than I don't know, which turns people off from using chatbots instantly. That's fascinating. I love that concept, and it's something I want to potentially employ if I'm going to be building any chatbots. All right, in our last sort of phase here, last 5-10 minutes, let's look a little bit further into the future. I've thought about this for quite a while in terms of either just straight up procedural generation of content, this idea of creating synthetic content, and tried to apply it to various industries. One of the difficult things that I came to a conclusion on is if it's based on style or design, there's lots of applications. We could do this in retail. We could do this in, creation of products, because we could have interesting, new, customized, personalized products created. It's more difficult to find other business problems to solve with this kind of procedural generation. So I did want to talk about a couple. One that did come to mind, and I did a little bit of research, and there are research papers associated with it. There's some things that DeepMind is doing lately around pharma, creation of drugs, creation of understanding of what proteins look like. A big data set that DeepMind just produced was around proteins and simulation of every possible protein, creation of new drugs. These are much more complex problems because the number of factors that you could go into for drug creation and trying to find leads on what you could do experimentation on. But that seemed to me to be a way where we could be, based on understanding of the way drugs interact and what the components of a drug chemical compound are, that procedural generation or this kind of synthetic data creation could be interesting. Where else have you sort of seen that go, and where are you sort of excited to get implementations of this kind of thing out there in other business domains?
Absolutely. I think there's a potential for a whole nother episode on drug synthesis and like the power of quantum computing on that as well. But specifically for synthetic data, what I see now is we're getting to a point where we can really create very highly relevant and specific visual data to actually train models for. So we've seen it in the past. We talked about synthetic data right at the start. We've been doing that for traditional machine learning for a long time. An example of that is like fraud detection. If I have 10 years worth of credit card data, I probably only have 1 or 2 instances of fraud. So we can actually simulate fraud in data to get a much better so our models can get a much better understanding. We're now at the point where using visual stuff, using some of the game engines. I've actually got my room on the screen behind me, which I've put in a Blender render, and you can see is kind of crazy, the likeness that you can get to. We can create like virtual scenes using gaming technology to actually generate loads of data that we can feed back into image analysis. So the example that I've worked on in the past is, how do you recognize grocery items, right? There's hundreds of thousands of different stock keeping units of grocery items. They all look slightly different. The example that I became slightly obsessed with was cereal. There's hundreds of different brands of cereal. Within those brands, sometimes they have like different size packaging that all like look fairly similar. How do we use a visual recognition system to recognize those without having to tag hundreds and hundreds of thousands of images? The same way that, there's lots and lots of different groceries is like one example. But if you think about like satellite imagery, we have gigabytes, terabytes of data of satellite imagery of the Earth over time. How, without actually going in and manually tagging those things, how can I possibly understand what's in them? Or how can I create a machine learning model that knows what is in those images without hundreds of thousands of man hours of tagging? Well, one answer is synthetic data. When we can create really high fidelity things like this, so you can imagine if we had a really high fidelity render of a 3D supermarket, we could actually stack the shelves. But with procedural generation, the thing is, where you put the items. So I know where I put my virtual cereal box because I'm the one who put it there. So then we can simulate the camera passing by, and we know where the cereal is already. So we can create a whole image data set that actually is pre-tagged. So we're generating the images with the tags, and therefore we don't have to do them on the real images. Now, I'm not saying that will get you 100% of the way, because it won't. There's always going to be a discrepancy between the simulated, a model that's built on simulated data, but it gets you most of the way. So then you can actually spend your time retraining the model with human tagged images of where things went wrong, and not wasting them on like doing it in the initial place. So I've got another image here, which is me trying to. No, that is actually me.
Here's the problem.
So
what's real and what's virtual?
Yeah, I have no idea. From the thumbnails alone, I don't know. But this is an example of, I was trying to use a MetaHuman and Unreal Engine 5 to kind of simulate what I might look like in a kind of virtual world. Now, MetaHuman Creator is an awesome tool from Epic Games. Highly recommended. It's a little bit difficult to make it look exactly like me. This is on screen. I've got like the best attempt I could of me sitting in my own bedroom, 3D rendered. But you can see like this is good enough. We could pass that through a facial recognition filter, and it would actually recognize that as a person. We can simulate lots of different emotions and create lots of very specific data sets from that. If you think about things like self-driving cars, for example, you think of the hundreds of thousands of hours that have to be of footage that have to go in. Well, actually, we could create that virtually with procedurally generated virtual worlds. We could put metahumans in places that they're not supposed to be and see if the system like recognizes that the car needs to stop, for example. So there's like loads and loads of really cool future models that we could train that are only going to be possible to train on synthetic data, because otherwise it's just too much manual input to try and get to the level of fidelity that we need, especially in safety critical applications like self-driving cars.
Especially when it's those kinds of unique situations that you might not expect or hope to never encounter. We're going to be developing a new nuclear power plant. And we're going to want AI models that are watching for a particular condition. And I would rather not have to go find a bunch of, 10,000 photos of nuclear meltdowns to train my model. So in those kinds of situations, being able to have something like GPT-3, something like DALL-E, everything put together, so I could suggest to it what this kind of thing should look like, and change a bunch of parameters around it, and have it generate then all of these simulated views of what these nuclear meltdowns look like, then train a model to watch for those very closely and watch for what leads up to them. That's amazingly interesting. It's a very common concept if people aren't familiar with how AI models, even back to just the very simple ones, I'm going to train a model to recognize pictures of a dog. When you're training that kind of model, you can get a bunch of pictures of dogs, and that's fine. But then often what you do to make the data set more complete is you rotate the picture of the dog, or you put the picture of the dog upside down and then add that to the model too, so that if you get to a situation where the dog is, lying on the couch, it doesn't not recognize the dog because it's only seen dogs straight up and down. So this is a much more advanced concept of creating and modifying existing data that we've seen, changing it in a way that creates new situations that then our model can recognize more effectively. That is fascinating. And the meta-human stuff from Unreal 5, we'll have a little bit here in the visuals, or I encourage anyone to look up some of the videos that are out there. That, as again, another tool to couple with this, where you can add so much emotion and fidelity, almost to the point where we're pretty close to getting past the uncanny valley, which is very difficult for us to achieve, which is the ability for humans, and a human, which we've got models in our own brains, which are very effective at understanding faces, because that's how we operate in a society. And the uncanny valley manifests when, because we're so good at doing that, looking at an artificial representation, our brains are very effective at picking up where the differences and flaws are. And that's what allows us to look at that and say, something's off, something's wrong, that's not real. Unreal 5, meta-human creation, being able to create live models of a human that can interact and talk and be rendered in real time is something that's just amazing and incredible. And getting past that uncanny valley.
Absolutely. And I would say I am not a game developer. Wouldn't even say I was like a 3D modeler, but I managed to create, what's on the screen, which is a kind of meta-human version of me in I would say a pretty good replica of my room. I mean, if we look at the Blender version, there's like reflections in there. There's all the furniture. It's just a little bit more neat and tidy than the real version. This comes back to the idea of like faces is much more difficult to get right. But the fact that I, as kind of I don't specialize in this, can get to this point. You can imagine what using engines like Unreal Engine 5, that the professional game developers, modelers, texture artists are going to be able to do in the very near future. It's going to be absolutely incredible, I think.
Yep. And there are games out there that already showcase close to what Unreal 5 is able to do. Things like Last of Us is an excellent example where you can just see the representation of emotion that's projected through these virtual representations of characters that don't exist. That's amazing. Okay, well, this is exciting. I love this idea of where we've gotten to now, where AI can be a partner to us and it can start helping us create things or be creating simulated data or simulated things on its own that we can then use. I'm going to have to use some of it. Maybe we'll get some new logos for my podcast here pretty soon. People can keep an eye out for that. But I really appreciate you jumping in here, Fergus, and sort of giving us the background on all of these pieces. This is an exciting area that I expect to continue to develop and change. This is a place where, although some of the basics of AI, I feel like have been relatively sedentary, useful, but sedentary for a number of years, this creation of new things and this layering of models in implementations like DALL-E and GPT-3 is where we're still seeing a lot of innovation, and I expect that rate of innovation to continue. So let's stay connected and come back together maybe in another quarter and see what else we've done. And when we get GPT-4 and, DALL-E 4 and, we just, speak into a microphone and do the Star Trek thing where we say, computer, create a holodeck version, a metaverse version of this. This is what I want to see. And we can go into it with our headsets and play around. That'll be amazing.
Absolutely. And I can't wait to see it.
All right. Well, again, thanks very much. And we will talk to you soon.
Thanks for having me, Jeff. Awesome.
This has been a Nexavize production. For video, links, and to support the show, please visit nexavize.com. That's nexavize.com.